So out of which, okay, so out of which two of them are actually astrological and three of them are astronomical. So those three is what we are going to discuss today. We have Tithi, Nakshatra, and we also have Vara. That is the days of the week. So let's start with the first element. So that is Nakshatra. So many of the people think that the translation of Nakshatra is constellation, or many people think that Nakshatra is just stars or a group of stars or zodiac, but that is not the case. Nakshatra cannot be translated as a constellation. Nakshatra can loosely be translated as lunar mansion or lunar asterisms, um, but not as a constellation. So let's take a look at what nakshatra actually is. So when ancient Indian astronomers wanted to study the sky, they started observing the patterns in the sky. They started observing the motion of the celestial bodies in the sky. They saw the moon rising and setting. They saw the sun rising and setting. They saw all the constellations rising and setting. So they wanted to track the motion of all these, and they wanted to use that in chronometry for measuring time. So nakshatra was a very useful invention. I wouldn't say it's an invention. So nakshatra was a very important concept that they created. And nakshatra is an Indian indigenous concept. It does not exist in other cultures as it does in India. There are some references in Chinese astronomy about lunar mansions, but nakshatra is unique to India. So that is, let's see what a nakshatra actually is. So when the ancient Indians started observing the night sky, they could see the moon traveling in the sky. And then they noticed that every night in the background of the moon, there are different stars. And then they noticed that after every passing night, the background of the moon changes. So it means the backdrop of the stars in the background of the moon, it changes every night. So they started observing that, okay, today the background of the moon is like this. Tomorrow, there are some different stars in the background. Day after tomorrow, there are different stars in the background. And then they started observing and noting these patterns in the background. And then they observed that approximately after 27 days, the moon returns to the same background of stars. So they noticed that when the moon travels through the sky, it has 27 different backgrounds. Those 27 are nakshatras. So basically, the moon stays in that background of stars for every night, and then for the next night, it moves into the next background. So that is what is nakshatra, a lunar mansion. Moon stays in that background for one night. That is what a nakshatra is. And so the lunar orbit in the sky can be divided into 27 parts, and those parts are called nakshatra. So that is what I've written here. Each part is called a nakshatra. Moon takes 27.3 days to complete one revolution and come to the same initial point. And so that orbit can be divided into 27 parts. And so each part is a nakshatra. So that is what a nakshatra is. So now let's take a look at the nakshatras. So you can just raise your hand if you do. How many of you know all the 27 nakshatras? Just raise your hand if you do. All 27. Okay, no problem. So we are going to see them now. So the first one right here, okay, someone raised their hand. I can see Kanishta Joshi saying that they know all the 27 nakshatras. That's good. Awesome. Keep it up. And okay, I see many people raising their hands. That's awesome. Great. So now let's take a look at all the nakshatras for the people who don't know their names. So the first one right there is Ashwini. And I've also tried to show the shape or the constellation in which that nakshatra resides. So this is Aries the Ram, Mesha Rashi, and the red point that is shown there, that's actually Ashwini Nakshatra. To be particular, that's the Yoga Tara of the Ashwini Nakshatra. Yogatara implies that it is the prominent star of that nakshatra. It is prominently seen with the naked eye. So that's the first one, Ashwini. Then we have Bharani, which is also in Aries, the ram, or Mesha Rashi, but then it is slightly towards the tail. So what we see here essentially is the moon on one day is, let's say, at, maybe I'll draw on it. Let's say the moon today was over here. So tomorrow the moon is going to be somewhere over here. So on this day, the nakshatra of the night was Ashwini nakshatra. On the second day, let's try to write down the names. On the second day, or to be particular, on the second night, the moon is going to be somewhere over here. So now it is in Bharani nakshatra. On the third night, it is in Kritika nakshatra. So Kritika is actually this entire thing. That's the Kritika nakshatra. But the Yogatara is right there. So that's the Kritika nakshatra. And the name Kritika comes from the six mothers of Kartikeya. So Kritika are actually the six mothers of Kartikeya. That is what Kritika is. And the names, let me try to remember the names. So it is Amba, Dula, Nitatni, Aprayanti, Varshayanti, Meghayanti, Upunika. So there are six stars in this particular thing. And that together is Kritika Nakshatra. You can see this with your naked eye. So if you have ever done Indian astronomy or naked eye astronomy, you can see this with your naked eye. It is called Pleiades in Greek astronomy. So that is the third nakshatra, Kritika. So when the moon is somewhere over here, the nakshatra of that night is Kritika. Then the moon moves forward and we have Rohini. So Rohini is a very interesting nakshatra. That's the Yogatara right there. And the name of that star in Western astronomy is Aldebaran. Aldebaran is a red giant. It's a huge, huge, massive star. And you can see it with the naked eye. It appears a little reddish in the sky, and it is called Rohini. And the shlok that that describes Rohini goes something like this: Satat urdhva rohat, sarohinya bhavat, tadrohinyai rohinitvam. So that is the shlok that describes Rohini. So when the moon comes somewhere over here, the nakshatra for that night is Rohini. Then as we move forward, we have Mrugashirsha or Mrugashira nakshatra. Mrugashirsha literally means the head of the deer. And there's actually quite an interesting story about Mrugashirsha. If we have some time at the end, then we can cover this story. In Greek, this is called Orion the Hunter. It is a very famous constellation. It can be seen prominently in the winter sky. So it's right there. The Yogatara is over here. So when the moon is somewhere at this location, the nakshatra for that night is Mrugashirsha, head of the deer. The next one is Ardra. Now there's a little astronomical dispute about Ardra. Some Indian astronomers of the past identified Ardra with this, the shoulder of Orion. And some people actually say that that is not Ardra. Ardra is actually the foot of Pollux, right here. But that's a part of the astronomical dispute. Generally, we will take Ardra at this location, but just keep in mind that sometimes Ardra is also identified with this star. Okay, so we have Ardra. So when the moon is somewhere at this place, then we have Ardra Nakshatra for that night. And so the list goes on. We have Punarvasu, then we have Pusha. Pusha is an interesting thing. So this is the Yogatara. It comes in Cancer. And the moon is somewhere over here. The nakshatra of that night is Pusha. In Greek astronomy, it is a part of Cancer, the constellation or the zodiac of Cancer. And the cluster which forms the Pusha is the beehive cluster. It is a globular cluster. No, sorry, it is an open cluster of stars. And you can see them with the naked eye. You need a very dark night for that to happen. And then we have Ashlesha. So right here is Ashlesha. So when the moon is somewhere over here, the nakshatra for that night is Ashlesha, and this is the Yogatara, the prominent star in that nakshatra. And this long thing, I'll tell the constellations later, but this is one of the longest or largest constellations that exist in the night sky. So the shapes that I'm showing, they are actually from Greek astronomy, but the stars that I have highlighted as red, they are the Yogatara of the Indian nakshatras. Then we have Magha right over here. So Magha is right here. The prominent star is here, Leo, the name. And the name of this star in Western astronomy, Regulus. So that's the name of the star. Then we have Purva Falguni, which is again in Leo. It is the tail of Leo or near the tail of Leo. So when the moon is at this location over somewhere, we have Magha Nakshatra. When the moon moves forward, then we have Purva Falguni. When the moon moves even forward, at this case, we have Uttara Falguni. The next literally means the hand. So this in Greek astronomy is Corvus the crow. That is the shape of Corvus the crow. And the prominent star in Indian astronomy, Yogatara, is right over here. So when the moon is somewhere at this location, we have Hasta Nakshatra. Then we have Chitra. In Greek astronomy, it is called Spica. It's a very interesting star. And the next nakshatra is equally interesting. But yeah, this is Chitra Nakshatra. When the moon is somewhere over here, we have Chitra for that night. Then we have Swati. Swati is Arcturus. It's a red giant. The star actually at that position is a massive star. It's a supermassive star, if you want to call it that. But that's Swati, Arcturus in Greek astronomy. Then we have Vishaka. Then we have Anuradha. This constellation is Scorpius, and this is Libra. So when the moon is over here, we have Vishaka Nakshatra. When the moon is over here, we have Anuradha. And we have Jyeshtha. The name of this star in Western astronomy is Antares. And the reason why it is called Antares is anti of Aries. So the red color of this star rivals the red color of Mars. And there comes a time when Mars is exactly near to this star. I mean, apparently near to the star. So that's why it rivals the redness of Aries, which is Mars. And so it's called Antares in Greek astronomy. In our case, it is Jyeshtha. Then we have Mula. So Mula is right over here. When you have the moon over there, the nakshatra is Mula nakshatra for that night. Then we have Purvashadha, that's the Yogatara. I'm just going to show the Yogataras now. Then we have Uttarashadha, that's the Yogatara. Then we have Shravana nakshatra. The entire thing is a nakshatra, but actually, in most cases, the entire constellation is not counted as the entire nakshatra. Then we have Dhanishta. So the Yogatara is right over here. It's in Delphinus. The Greek astronomy name is Delphinus. Then we have Shatabhisha or Shatataraka, and that's the Yogatara. Then we have Purva Bhadrapada. The Yogatara is over here. The Greek name for this is Pegasus. And this is called the Great Square of Pegasus or the Maha Ashwakon. And the Yogatara, as I mentioned earlier, is right over there, Purva Bhadrapada. Then we have Uttara Bhadrapada. And finally, the last nakshatra is Revati, which is right over here. And that's the Yogatara of Revati. And once the moon comes over here, now we have reached all the 27 nakshatras. And again, the nakshatra that comes after this is back to Ashwini. So that is how the journey happens. So these are the 27 nakshatras. We have covered each and every nakshatra and the names. So now you know that basically nakshatra is the background of the moon. The lunar orbit can be divided into 27 parts, and each part is called a nakshatra. So that was the first point of Panchanga. Now let's take a look at the second point. We are only going to see 3 points from Indian astronomy because the remaining 2 points are actually astrological. Yoga and Karna are not astronomical. We are not going to touch that. So let's take a look at the second one. Vara. So we have heard of days of the week, right? We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. In Indian names, we have all, like Shanivar, Ravivar, Somvar, Mangalwar, Budhwar, all kinds of stuff. 7 names we have it. But have you ever wondered why the names are arranged in this sequence? Why this particular sequence? If you actually take a look at the sequence, they are named after planets. They are named after grahas. But the grahas in the sky, they are not in that sequence. I mean, obviously, we have Shanivar, and Ravivar follows Shanivar. But if you take a look in the sky, we see the sun, and Saturn is actually way far away from the sun. So why are Shanivar and Ravivar placed close together? Why? What is the reason for that? What is the reason for naming the months, or sorry, naming the days of the week in that sequence? So let's take a look at it. So I'm gonna write some stuff down. It's easier that way. So in Indian astronomy, this has partly an astrological explanation, but most of it is astronomy. So the explanation is twofold. The astrological reason is there were two concepts in Indian astronomy. One was called Horadipati, and the second was called Dinadipati. And you have to excuse my handwriting, but I think it's readable. Okay. So these were the two concepts in Indian astronomy, Horadipati and Dinadipati. Now, if you split the words, Hora and Dina, so the first word means Lord of the hour of the day. There are 24 hours. So Lord of the hour is Horadipati, Pati of the Hora. And then we have Dinadipati. Dina is day. So Dinadipati is Lord of the day. That is what Dinadipati means. So basically, the concept was that every hour of the day was assigned to a certain graha. Okay, and hear this. Hearken. Every hour of the day was assigned to some graha, and the graha to which the first hora of the day was assigned, that graha was used to name that day. So basically, if the first hora of the day was assigned to Saturn, then the name of that day is Shanivar. I hope that makes it clear. So the first hour of the day belongs to Saturn, then Saturn is the Horadipati. And since the first hour belongs to Saturn, the first hour of the day belongs to Saturn, Shanivar becomes the day. So Saturn is both Horadipati and Dinadipati in this case. So I hope that makes it clear. I'll just write it down. So these two are astrological concepts. So that is what it means. So let's take a look at the explanation. So the word graha actually it has a split etymology with gruha and grahan. So when you take a look at Indian rituals, there are 7 kinds of you could say boxes. I've just drawn boxes, but you could say that there were 7 types of structures that were arranged with rice, and there's a small supari on top of it. So those were actually gruhas. So how do you plot the days of the week? So let's start. The step one to name the days is arrange all the planets in the decreasing order of the revolution periods. So the slowest among them is Saturn. Take a look at the revolution period. That's 30 years. So Saturn takes 30 years to complete one revolution, which means in the sky, Saturn takes 30 years to come back to the same position. 30 years in the same constellation. So Saturn is the slowest. That is why the name of the planet is Shanaishcharaha. Shanaishcharaha. Shanaihi. Then we have Jupiter. That is Brihaspati. Brihaspati is a little faster. It reaches the same zodiac again after 12 years. Then we have Mars. Then we have the sun. Remember, this is a geocentric system. Ancient Indians used a geocentric system. So the sun's revolution period is counted instead of the earth's. So we have the sun. That's 1 year. Then we have Venus, 225 days. And then we have Mercury, which is for 88 days. And finally, the fastest object in the night sky, that is the moon, 27 days, as we have seen right now. 27 days to complete one revolution. So once you have arranged all the planets in the descending order of their revolution periods, slowest to fastest. Remember, slowest to fastest. Now we start assigning the hours to the planets. So let's draw on this one. So the first hour of the day belongs to Saturn because it is the slowest. This is where our sequence starts. So our first day, first hour belongs to Saturn. So Saturn is the Horadipati of the first hour. And as per our definition, Saturn is also the Dinadipati. So that's why the name of the day is Shanivar. Now let's see. So the first hour belongs to Saturn. That's why Shanivar. Second hour belongs to Jupiter. Third hour belongs to what we have here is Mars. Fourth hour belongs to the Sun. Fifth hour belongs to Venus. Sixth hour belongs to Mercury. And seventh hour of the first day belongs to the Moon. Now again, the cycle repeats. So we have 8, 9, 10, 11, 12, 13, 14, 15. And when you proceed in the sequence, 22, 22nd hour of the first day will also belong to Saturn. 23rd hour of the first day will belong to Jupiter. And now see what happens. 24th hour of the first day belongs to Mars. Now there cannot be a 25th hour of the day. So the 25th hour becomes the first hour of the next day. And which is the next day right here? That is the sun. The first hour of the next day belongs to the sun. The sun is the Horadipati and also the Dinadipati. And that is why the second day is named Ravivar. So that is how the sequence proceeds. So we have covered all the 24 hours, the 25th hour, that is the first hour of the next day, we have Ravivar. So that is exactly where the one is pointing. So I've put together a table to explain it better. Oops, maybe I'll zoom it out. Okay, take a look at this. So this table shows you how the days of the week are actually named. Look at this. You start with Shanivar, and since this is Hora 1, the name is Shanivar, second hour, third hour, fourth hour, fifth hour, sixth hour, seventh hour. Go back to the cycle 8, 9, 10, 11, 12, 13, 14. Go back to the cycle 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This is where the first day ends. And look at what happens. That's the magic. Or you could say that's actually a logic. So we have Ravivar. You proceed again all the way around. You have second day ending here. Somvar. You go all the way down. Mangalvar, Budhvar, Guruvar, Shukravar, back to Shanivar. As simple as that. It's very logical. So that is how the days were named. And this is honestly an ingenious method. This method was first actually developed by Babylonians. And then Greeks learned it. And somehow this method was transferred or borrowed into Indian astronomy during Yavana Jataka or Sputi Dhaja's Yavana Jataka. So yeah, mean days start from Shanivar, yes. And now there's also a formula. So this is an Indian invention. So there's a formula to convert, or basically it's a formula that gives you the vara of the Gregorian calendar dates. So this here is the formula. So if you want, I'll pause the screen. You can take a screenshot if you want, but this is the formula by which you can calculate the vara of any Gregorian calendar date. And then there's an example which I've given. So let's say you want to calculate the vara on 5th of August, 2020. You need to know what vara it was. So you use the formula You enter the numbers, and then you substitute the values. Sunday stands for 0, Monday stands for 1, Tuesday 2, Wednesday 3, and so on and so forth. And finally, the value that you get here is 3. And so it was a Wednesday. And you can actually go back to your calendar if you want. You can cross verify. 5th of August 2020 was indeed a Wednesday. So this is a simplistic formula, a mathematical formula that was invented by Indians. So this forms the second concept. The first one was nakshatra, the second is vara. Let's take a look at the third concept. We have tithi. So this is a very interesting concept. Many people have no idea what tithi is. So tithi, in simple terms, is a lunar day. Divasa is a solar day. Tithi is a lunar day. That's the difference between the two. So lunar day is what we are talking about. An ancient Indian calendar, that is the Hindu Panchanga, uses tithi and not divasa. So let's take a look at it. How do you calculate tithi? So maybe I'll add another page for us to perform the calculation. Okay. So how do you calculate the tithi? It's a lunar day, right? And now the moon is moving and the sun is also moving, but the earth is stationary. So let's use relative velocity. So we have to calculate the velocity of the moon with respect to the sun, because that's the only thing that is moving in the sky for us to measure. I mean, there are planets and stars moving, but sun and moon is what we are concerned with. So we have to calculate moon with respect to sun. So that's simply going to be Vm minus Vs. But these are velocities with respect to Earth. So when I say Earth is stationary, it means in a geocentric system, Earth is stationary. Ancient Indians used a geocentric system. But it still gives you the same answer. Try to take a look at it. So these two, Vm and Vs, they are the velocity of the sun and the moon with respect to the Earth. So let's take a look at it. We know that the moon takes 27 days to complete one revolution. So that's 360 degrees divided by 27. And we know that the sun takes 365 days to complete one revolution. Remember again, this is a geocentric system. So the sun takes 365 days to complete one revolution. So that's going to be 360 degrees divided by 365. So the first term is around 13.33. The second term is, I don't know, around 0.9 maybe, looks like that. For simplicity, we're going to take 13 minus 1. So that gives us 12 degrees. So this is the relative velocity between the moon and the sun. This is what is a tithi means. So let's try to get the physical understanding of what we did right now. On the day of Amavasya, the moon and the sun have 0 east-west distance between them. They are exactly at the same ecliptic latitude. That's why we have an Amavasya. So what happens is, on the next day, since the moon is faster, the moon moves forward in the sky, but the sun does not, because the sun is very slow. It takes 1 year to complete one revolution. But the moon can move forward because moon is very fast in the sky. It just takes 27 days to complete one revolution. So the moon moves ahead on the next day, while the sun is still almost at the same position. In 1 day, the moon covers a distance of 12 degrees from the sun. This gain of 12 degrees by the moon on the position of the sun in 1 day, that is Pratipada, first tithi. From the Amavasya, the first 12-degree change in the first day is Pratipada. This is the first tithi. On the second night, the moon would have moved 24 degrees. Dvitiya. On the third night, the moon would move 36 degrees and the table of 12. Now you will wonder what happens when it reaches 15 days. That's when we have a Purnima. So the moon is almost 180 degrees from the sun. So we have a Purnima. And even the math is mathing. So you multiply 12 and you multiply that by 15, you almost get 180 degrees. So yeah, so that's 12 degrees. That's Tithi. So let's take a look at the actual thing. So this is the same thing that I've done right now above, but the image was not clear, so I just try to do it again. That's all. So this is the calculation. If you want, you can take a screenshot. I'll just pause the screen for a second. But yeah, this is pretty much the explanation for Tithi. Now there's one interesting thing that happens with the Tithi, which is called Tithi Vruddhi and Tithi Kshay. So if you take a look at Indian calendar, you'll notice that sometimes same Tithi is repeated for 2 days. And sometimes a Tithi is skipped. Yesterday it was Tritiya, and suddenly today, in just 24 hours, it is Panchami. There is no Chaturthi. So that's surprising. That's confounding. So people have no idea why that is happening. So there's a very astronomical explanation for that. You could say a logical explanation for that. So let's take a look at that. To understand why there is a Tithi Vruddhi and a Tithi Kshay, we have to recognize one rule, because clearly what we did above is kind of complex. It's astronomical. Not every layman is going to be familiar with how to do or how to calculate relative velocities. So there needs to be a thumb rule, that any foolish person can follow. So that thumb rule is this. So whatever is the tithi of the moon during the sunrise of the day, that is the tithi of the entire day. That's the thumb rule. We are going to follow this thumb rule. The tithi at the sunrise is the tithi of the day. As simple as that. This is for the layman. But this leads to some interesting things. Now we know that the moon revolves around the sun in an elliptical orbit. So when it's going to be closer, the moon revolves around the earth in an elliptical orbit. So when the moon is closer to the earth, that point is called perigee. And then when the moon is farther away from the earth, that point is called apogee. And if you follow on Kepler's laws of planetary motion, we know that when the moon is going to be closer to the earth, perigee, it is faster. It moves fast. Whereas when it is at the apogee, it moves slowly. That's just Kepler's law of motion. But the result of that can be seen here. Let's take an example. Let's say on 28th of July, during the sunrise, you had Saptami. Okay, during the sunrise of 28th of July, you had Saptami. Now the sunrise occurred, so we have Saptami, and on 29th of July, there's going to be Saptami. And let's say the moon is at apogee, farthest from the earth, so it's going to be slowest there. Remember, farthest and slowest. So what happens here is, since the moon is farthest from the earth, it is also slowest. So by the next sunrise, the moon actually does not enter into the next tithi. See what happens here. The entire day goes on, and finally there is night, there is sunrise, but the moon enters the next tithi after the sunrise of 30th of July, after the sunrise. So during the sunrise, the tithi was still Saptami. And during the sunrise of yesterday, the tithi was still Saptami. And the reason for this is the moon moved into the next tithi after the sunrise. That is because the moon is slowest at the apogee. So that is why the same tithi is repeated for 2 days. So that's where we have tithi vruddhi. So this is the explanation for tithi vruddhi. The exact opposite explanation is for tithi kshay. Oops. So let's take a look at tithi kshay. So now what happens is, now the moon is at the opposite position. Let's imagine the moon is at perigee. So when the moon is going to be at perigee, it is going to be the fastest. So it is going to cover the distance by moving faster. So what happens in this case is, let's take the same example. Let's say during the sunrise of 29th of July, the moon was in Tritiya. Okay, during the sunrise of 29th of July, the moon was in Tritiya. So, our thumb rule, it's going to be Tritiya on 29/7. But now what happens is moon is moving faster. So it moves into the next tithi before the sunrise. In the earlier case, it was after the sunrise. In this case, the moon moves into the next tithi before the sunrise of the next day. So what happens is the day goes forward, the moon enters from Tritiya into Chaturthi, and even before the sunrise of the next day, the moon has already entered Panchami because it is moving faster. So what happens is on the next day, the sunrise, during the sunrise, the moon has already entered Panchami, while yesterday it was still in Tritiya, and just a day has elapsed. So in this case, Chaturthi is skipped. So this is called Tithi Kshay. So this is simply because of the motion of the moon. The moon is fastest, the moon is slowest, but this is the reason for that to happen. Quite straightforward, quite astronomical, and it is logical. But these two are important things. And now the last topic of today's talk is Masa, that is the month in the ancient Indian calendars. So in the ancient Indian system, there were two ways to define months, two types of calendar systems. So the first one was called Amavasyanta or Amanta, as the name suggests, Amavasya Anta. And the second one was called Purnimanta, Purnima. It ends with Purnima. Amavasyanta ends with Amavasya. So let's take a look at what it actually means. Let's take an example of Amavasyanta system because majority of the Panchangas in India today follow the Amavasyanta system. So I have a figure here. Maybe I'll enlarge it. Okay. So in this case, we have an Amavasya right over here. Amavasya, Purnima, Amavasya. Okay. So in Amavasyanta system, a month is measured between two successive Amavasyas. That's what I've shown here. Now, as the moon moves from Amavasya to Purnima, it is getting whiter, it is getting brighter. So that's why it is called Shukla Paksha. Paksha is a fortnight, Shukla is white, basically. So since the moon is getting brighter from dark, the Paksha is called Shukla Paksha. And we have 15 tithis, which we have learned earlier, which means the moon has already completed 180 degrees from the sun, and now it is at opposition. So that's Purnima. So 15 tithis. And similarly, as it goes from Purnima back to Amavasya, the next Amavasya, what we have is Krishna Paksha. Krishna literally means black, Paksha is fortnight. And there also we have 15 tithis. So together, in the Indian calendar, a month is of 30 tithis, which is equivalent to 29.5 days. Remember, tithi is not a divasa. Divasa is a solar day. Tithi is a lunar day. So it's going to be shorter in duration than the solar day. So the terms that we use every day, that's divasa. That's day, just day. But lunar day is specifically used in astronomy, in Indian astronomy. Okay, so we have 30 tithis. And as we can see, in this month, there is only one Purnima. So that Purnima has significance. That Purnima counts. So let's try to see how this Purnima of every month is used to name that month. Okay. So I have presented a chart in front of you. Try to take a look at what you see in them. So we have the name of the month, and then we have the nakshatra on the full moon day. So the nakshatra, which was our first topic, we covered that. We saw all the 27 nakshatras. Try to see the similarity between the names of nakshatras and the names of the months. So I'll explain what is happening here. Since in every month in the ancient Indian calendars, month is measured between two Amavasyas, and between two Amavasyas we have one Purnima. The nakshatra which is in the background of the moon during the Purnima, that nakshatra is used to name that month. I'll repeat once again. Between two Amavasyas, that is one Purnima, the nakshatra in which the Purnima occurs in that month, that nakshatra is used to name the month. So that is how the Indian name months are named. So let's take a look at this. The name of the first month is Chaitra, which means the full moon of Chaitra Masa occurs in Chitra Nakshatra, which means whenever there is a Purnima, the nakshatra in the background is Chitra. Then we have Vishakha, which is the name of the nakshatra where the full moon occurs in that month, and so the name month is named Vaishak. Then we have Jyeshtha, Jyeshtha, Purva, Shara, and Uttara, Shara, Ashara. Then we have Shravana, Shravan. Then we have Bhadrapada, Bhadrapad. Then we have Ashwini, Ashwin, Kritika, Kartik, Margashirsha or Mrugashirsha, Margashirsha, Pusha, Pausha, Magha, that is Regulus. We have Maga. And finally, we have Purva Falguni, Uttara Falguni, and the name of the month is Falguni. And on every Purnima, there is a festival that is associated with it as a reminder that it's Purnima today, and so you have to celebrate it. There's just one Purnima in the entire month. So this brings us to the end of the lecture. We just covered 5 topics. We have the nakshatra. Okay, I'll just go up. Yep. So we saw nakshatra, then we saw tithi, then we saw vara, and then we saw masa. Now, masa is not actually a concept in Panchanga, but it is related to Panchanga. That is why I explained the concept. Yoga and Karana, which are the two remaining angas of the Hindu Panchanga, they are astrological, and we are not going to discuss astrological concepts because, first of all, Indian astronomy is very important to learn. Second, astrology has no scientific base. So it is there is nothing interesting to cover in astrology. It's predictive astrology, but it has no scientific base. So astronomy does, and this is Indian astronomy. So I'll just mention that in tomorrow's lecture, we are going to see Vedanga Jyotisha, we are going to see Surya Siddhanta, we are going to see the discoveries by Indian astronomers like Aryabhatta, Brahmagupta, Varamira, Lalla, Shripati, and then we are going to see the yantras that are used in Indian astronomy, and then finally we are going to see the work of Indian astronomers on eclipses. That's very interesting. And what are the types of Indian astronomical texts? So with this, I think I would like to end today's lecture. Maybe I'll stop screen sharing. And now it is okay. Hold on. Okay. And I guess now we can have questions if you have any questions.
A few people have already asked questions in the chat box, so if you can take a look at it and answer their questions.
Okay. Chat box. Okay. So the first question is it because of gravitational force? I guess you're talking about the moon and the earth. Yeah, it is because of the gravitational force. That's just Kepler's law of motion. But how would a common man know that it's the same tithi? That's an interesting question. So this actually occurs when you study Siddhanta or Karna or Tantra. So usually there's a handbook which used to be there, just like our calendar, which we hang on our ceiling. Maybe not on the ceiling, on the wall, but that was used in ancient India. And that is a very basic system for the layman. All it shows is the tithi and nakshatra. That's it. It doesn't give any details that are covered in Siddhanta. Siddhanta is a full blown astronomical treatise. So, yeah, that is how common man, layman can know about the tithi. Tithi Kshaya, explain one more time. I'll just give a brief idea. Tithi Kshaya occurs when yesterday the tithi was, for example, Tritiya, and the next day the tithi was Panchami. So the tithi in between was skipped. So that skipping of the tithi is tithi kshay. And that occurs because moon is faster or slower depending on if it is tithi vritti or tithi kshay. It's exact opposite of tithi vritti. Why is Kojagari Purnima highlighted? So I mean, we'll get to that tomorrow. So that's an interesting question, but it needs some astronomical background for that. Will you be sharing the resource material? Maybe I will share that with Bharatian and Bharatian can distribute it. What do you think about the weather prediction, which is quite accurate in Panchanga? Weather prediction is not even accurate in science, to be honest. Meteorological studies do predict weather, but they are not that confident. It's all about turbulence modeling and all about it's all fluid mechanics. Even they cannot predict it correctly, neither can Panchang. So we don't need to peddle pseudoscience. Question. It's quite famously observed and mentioned in folklore that moon spends its most time in Rohini Nakshatra. Is that correct? If yes, how does that impact the lunar mansion of 27.5 days? So for this, I have an entire video that is made on nakshatras on my channel, Project Satyalok. I'll just tell you one word answer to that, lunar occultation. Just Google that. The answer to your question is lunar occultation. Aldebaran, occultation in particular. Aldebaran is Rohini, occultation of the moon, or sorry, occultation of Aldebaran with the moon. That's occultation of Rohini. Could you elaborate on what you mean by moon being 180 degrees ahead of the sun? So basically, what I mean to say is in the sky, if you draw an arc around the earth, when moon and sun are opposite to each other, that's called opposition. This is called conjunction. This is called opposition. That is when a Purnima occurs. So what I mean to say is the moon is ahead of the sun by 180 degrees. So that's 15 tithis. Okay, so that's what it means. Yes, it is possible that moon revolves faster in Titiksha. That's possible. All astronomers in Vedic history are also the ones who wrote the treatises on Jyotisha. So is the science of astronomy basically psychological science of Jyotisha? So yeah, there's a weird mix of astrology and astronomy in Indian astronomical system. It is predominantly astronomy, timekeeping, chronometry, to make the calendar more and more perfect. But astrology was a little added to it because the astronomers had to fill their bellies, but then it has no scientific base. Predictive astrology is a pseudoscience. There is no reason to believe that planets have an effect on us individually and on our future. So yeah, yeah. I mean, there is a psychological case behind that. It's called Barnum effect, and it's a cognitive bias. That's all. Okay, there are many Jyotishacharya and tell us different. Okay. So to consider if it is a Titikshaya or not, the best way to verify is learning a Siddhanta. If not, then learning a Karana. If not, then learning a Tantra. And you can study that on your own. I do have the book here right in front of me. This is Surya Siddhanta. That's used by Saurabh Paksha of Indian astronomy, which we will cover tomorrow. Um, Ghatika and stuff, those are smaller chronometric units. They are used in calculating muhurtas, which we might cover in another session. Maybe not tomorrow because that goes deep into mathematical calculations. But yeah, that is Ghatika related to muhurta. Okay, thank you for this wonderful session. Yeah, you're welcome. Where do we see Purnimanta system being used? So I'm going to cover the number of calendars that are used across India. Different parts of India used to use different types of calendars. Amavasyanta was used predominantly. So that's why I discussed Amanta system or Amavasyanta system. Pictorial depiction of constellation was not there in Indian astronomy. Yeah, the constellation were not pictorial. There is no concept of constellation in Indian astronomy. It's nakshatra, and nakshatra is basically again the lunar orbit divided into 27 parts to track the motion of the moon. So that's nakshatra. Then how do they identify which nakshatra it is with the help of Yogatara? So Yogatara, the coordinates, X and Y coordinate of Yogatara in the sky, celestial coordinates, are called Bhoga and Shara, and they are measured from the ecliptic. So ecliptic is ionic vrutta, the path of the sun in the sky. If you draw the locus of the path of the sun in the sky, that's ecliptic. To the east-west, we have Bhoga. To the north-south, we have Shara. So those are the coordinates of the Yogataras. Might sound silly. Is there a reason they consider the revolution time of planets till Saturn? Um, the reason why they consider it as Saturn is because that's the slowest planet that we see in the night sky, and those are the only planets which are visible to the naked eye. Uranus and Neptune did not exist in Indian astronomy. Uranus and Neptune did not exist in any other astronomy of the ancient time because Uranus and Neptune cannot be seen with the naked eye, right? So it needs telescopes. So everywhere that you see on Instagram, people claiming that Uranus and Neptune were known to the ancient Indians. No, they were not known to the ancient Indians, neither to Greeks, neither to Mayans, neither to Egyptians, neither to Aztecs. They cannot be seen with the naked eye. That's why in the Navagraha, we do not have Uranus and Neptune. We only have the five visible naked eye planets: the Sun, the Moon, Rahu, and Ketu. Rahu and Ketu are not Uranus and Neptune. Rahu and Ketu are lunar ascending and descending node. This was very important to mention because I see many posts on Instagram making such claims. So, but yeah, either way. Yeah, so Patra, which is used by Pandits. Yes. So Ghatika Patra is used by Pandits during the ritual. That is again a measurement of Muhurta. There is a time span of 48 minutes that they measure. So yeah, I will be covering Patras in tomorrow's lecture. Yes, Saturday is the first day. Titikshaya is moon faster. Titivriti is moon slower. Very good. Beginner's Guide for Learning and Understanding Jyotisha. A very good book to understand Indian astronomy. You can all note it down if you want. Indian Calendar or Bharatiya Jyotish Shastracha Itihas. Um, that's by Bal Krishna Dikshit. Indian Calendar, Bal Krishna Dikshit. Maybe I'll put it in the chat. Indian Calendar. Oops. Bal Krishna Dikshit. Okay. So that's the name of the book which you can download. He has done the most astounding work on Indian astronomy, and it's a classical book for learning Indian astronomy. Okay, I guess I cannot see any more questions in the chat.
Yeah, that's it then for today. So
Okay.
I hope you all learnt a lot today, and you'll join tomorrow as well for another session. The time is same at 12 p.m. 12 p.m. to 1 p.m. Indian time. Okay. Yes. So if you have any more questions, please note them down. We'll be having a separate Q&A session tomorrow as well after the session. You can ask the questions then. Okay. Thank you everyone for joining.
Thank you, everyone.
I think there's a question.
Yeah, go
Um,
ahead. You can ask.
yeah, I guess Prakhar had a question. I think he left. Yeah, go ahead, Nachiket. Yeah, I guess Nachiket, you can unmute yourself and maybe ask the question. It's easier that way instead of typing in the chat. Oh, I guess the audio is switched off for everyone. Okay, yeah.
Yeah. Hi. Hi, Bhargav. I'm
Yep,
talking
I can
about
hear you.
the Panchang weather prediction,
Mhm.
which is used. They used a method called Vahan. Can you elaborate on that?
For the prediction, was it for the prediction? I cannot hear you anymore. Okay, so I guess yeah. So the method that you're referring to, it's actually in Phala Jyotisha, in predictive astrology. So I have not really studied predictive astrology because I mean that goes into Phala Jyotisha. I'm basically familiar with Indian astronomy. So if you need someone to understand that concept, you'll have to meet an astrologer. I'm not an astrologer. I'm an astronomer. So, but yeah, that's a good question. Or maybe you can just use Google. But if you refer to Bharatiya Jyotish Sa Itihas or Phala Jyotisha, any text, they will definitely give that. Who created the analogy for calculation of the day? It was actually created by Babylonians and I guess Mesopotamians. Yeah, it did not originate in the Indian subcontinent. It was borrowed through Greek astronomy into Indian astronomy. Even the concept of rashis, that is zodiac, it does not exist in the Indian astronomy prior to the Greek borrowing. So the concept of zodiac or Rashi actually comes from Greeks into Indian astronomy. And you'll see many pages on Instagram trying to say that everything originated in India, including, the days of the week and the concept of zodiac and stuff. It did not. But what was invented in India, people have no idea about it. And so it creates a sense of false pride. So that is what we need to get rid of. We need to know what the inventions are instead of making ridiculous and falsifiable claims. Yeah, I guess there was one more question in the chat. Okay, so yeah, the three anga that we covered today, those are related to astronomy. So that's why I covered that today. The remaining two are yoga and karana. They are kind of astrological. So I don't think I'll be covering that in the lecture today or tomorrow. But you can always read about it. You can download any peer-reviewed book on Indian astronomy, and they will explain that. But that's again astrological. It has nothing to do with scientific or observation. It's just predictions based on cognitive bias. Oh, I did suggest a book in the chats, so you can take a look at that. Indian Calendar by Balkrishna Dikshit. Okay, then I guess we are done for the day.
Yeah.
Okay.
So we'll meet tomorrow at the same time, 12 p.m.
Yep.
Yeah. Okay. Thank you. Have a good day.
Hello.
दोन मिनिटं.
Yeah.